Hey, it's Marcia here, and this week we focused on the physics of the egg drop challenge to see if we could come up with a predictor for damage. And if we could use that to design an experiment that would give us more insights into what's happening. And also if we could come up with a great crash test dummy. Okay, so let's go back a step. Okay, so we looked at potential energy. And we recognize that as we lift an object, we put potential energy in as we raise it above the ground, equal to the mass of the object times the gravitational constant of the planet that we're standing on and the height above the ground. Okay? So we can increase potential energy by increasing the height or increasing the mass. Now for egg drop, we're just interested in an egg. And we're going to use a fairly standard egg, so we're going to assume the mass is constant. So that means the magic of the potential energy we're putting in all has to do with the drop height. Okay, so at the top of our reach, we have maximum amount of potential energy and zero kinetic energy. Potential energy is stored energy, and kinetic energy is moving energy. Once we release it, the ball drops to the floor and it achieves the maximum amount of kinetic energy just before it hits the ground. So the kinetic energy in any object can be represented as 1/2 times the mass times the velocity squared, which is just velocity times velocity. Okay, so for our egg drop, our egg's mass is going to be pretty constant. Not a lot of variation there. We're not trying to do exercise ball versus, egg. We're doing egg and egg, okay? Which means the more velocity, the more kinetic energy. Okay, so it seems like we got a bit of an equation coming on that we can solve for, okay? And this is where I hypothesize a parameter for damage equal to momentum, which is mass times velocity. And I can solve for the velocity of an object from a given drop height by saying at my maximum height, potential energy is mass times gravitational constant times height. Okay? Just before impact, the kinetic energy is 1/2 mv squared, and the potential energy is 0. Okay, so I go from total potential energy up here, total kinetic energy down there. I set the two halves equal to each other, solve for V, and I get V is equal to the square root of 2gh. Okay, the only thing you need to care about is velocity. 2 and g are constants, so velocity increases as height increases, but not a linear relationship. Okay, and momentum is equal times m times v. So therefore, momentum is m times 2 radical 2gh. Okay, so more damage. Okay, more damage as I increase the drop height. Okay, so that's the foundation for this little design of experiment.